Magnets have north poles and south poles. Opposite poles attract, like poles repel. Some things are magnets, some things are magnetic, meaning they can be attracted by a magnet, and some things are non-magnetic, meaning they can't be attracted by a magnet. Magnetic materials are things like iron, cobalt, nickel and steel. Non-magnetic are things like aluminium, copper, plastic, wood. Permanent magnets are made of magnetic materials, usually steel. If we hang up a magnet, the north end of the magnet will point to the geographic North Pole, where the polar bears are. So we sometimes call this a north-seeking pole and a south-seeking pole. We make use of this when we make a compass, because the needle is a very small magnet and the north-seeking pole points north. But if a compass points north, it must be attracted to something in the Earth, which must mean the Earth has a magnetic core, a little bit like a bar magnet. But if the north end points north, the bar magnet must be the other way round, which means the north geographic pole must have a south pole of a magnet. Sounds weird, but don't worry about it. It also turns out that the magnetic poles aren't quite at the same place as the true poles. They're offset a little way. This is somewhere in Greenland, but they're close enough for most navigation. Why do magnets attract and repel? All magnets have what's called a magnetic field around them. A magnetic field is a region around a magnet where a magnetic material or another magnet experiences a force. We can visualise the magnetic field using lines of force drawn around a magnet. To draw the magnetic field around a magnet, we use a plotting compass, and we move it from place to place. The typical shape of a magnetic field around a bar magnet looks like this. For a horseshoe magnet, it looks like this. The field lines have arrows drawn on them, showing which way a compass would point. They always point from north to south. The magnetic field is strongest where the field lines are closest together at the poles, and weakest where the field lines are further apart. When two magnets are near each other, their magnetic fields interact, and this produces a force. For magnets repelling, the field lines look like this. For magnets attracting, the field lines look like this. I think of it as a slice through an onion. This is a permanent magnet, but this is just some magnetic material. The permanent magnet induces magnetism temporarily in the magnetic material. The effect is to attract the material. It temporarily induces magnetic poles like this so that it's attracted. When we move the magnet away, the induced magnetism disappears. It's as if the magnetic material contains little magnetic regions called domains. Normally, they're all jumbled up in pointing in different directions, so there's no overall effect. But when a magnet is near, they line up, making the material into induced magnet temporarily. We can illustrate the idea using all these compasses. They're all pointing in different directions. It's as if these compasses are like the magnetic regions within the material. If we bring a magnet nearby, they start to point towards the magnet, and we induce magnetism because they all point the same way. When we remove the magnet, they jumble up again. This is known as induced magnetism.